Net charge on that particular body would be given by Q1 plus Q2 plus Q3 and so on. This is the algebraic sum. This is the algebraic sum. Charge is a scalar quantity. This also we'll discuss later on. So charge is a scalar quantity. So this is again a very, very important property, right? So 3 properties which we have discussed. Charge is conserved, charge is quantized, charge is of additive nature. Then there is another property, invariance of charge. Invariance of charge. Invariance of charge. Invariance. It means that the charge on a body, it does not depend upon the motion of the body. Whether the body is at rest or whether it is moving, the net charge on that body will remain same. So that is known as invariance of charge. Understood now? While dealing in +1 physics, we have discussed the mass of a body does depend upon its motion. When we are talking about relativity, not in mechanics, there the mass of a body varies with this increase in the speed of the body. The mass of the body also increases. I am talking about in those cases where the velocity of the body is comparable to the speed of the light, right? So charge is invariance of charge. So it means that the net charge on a body do not depend upon its motion. It is independent of the motion of the body, right? Then charges, as we have discussed, it can be positive, it can be negative, and in case it is electrical neutral, then the net charge on that particular body would be 0, right? So these are few properties of charge. Its SI unit is coulomb. Then you're aware, like charges, it tends to repel each other, unlike charges, it tends to attract each other. Anyway, this is an important concept. Suppose a system comprises of 2 charges where Q1, Q2 is greater than 0. Can we predict the nature of the force existing with these 2 charges, whether it is attractive or repulsive? We can easily predict. I mean, use your aptitude, mathematical aptitude. Product of these 2 charges, Q and Q2, is positive, greater than 0. It means that it is feasible only when either both are positive or both are negative, isn't it? Both Q and Q2, either both are positive, both are negative. Product of plus plus, that will be greater than 0. Product of minus minus, again it will be greater than 0. So what we conclude is, if Q1, Q2 is greater than 0, it means that we are talking about like charges. And we are aware, like charges always tend to repel each other. Clear? Experimentally it can be verified, like charges repel each other. While on the other hand, if you consider this example, Q1, Q2 is less than 0. In this case, it is possible only when you are talking about different nature charges. I mean, charges of different nature. It is feasible only when one is positive, the other one is negative, or the previous one is negative and the second one is positive. So we are talking about unlike charges. So definitely, the nature of the force existing in these 2 charges must be attract. Isn't it? So, before we proceed with Coulomb's law, we can discuss one more basic topic. I mean, in +1, we have discussed the concept of mass in detail. Right now, we are dealing with the concept of charge, right? So, let's bring out the difference between charge and mass. In that way, we can revise the topic which we have started in +1 as well, right? So, mass and charge. First, definition wise. Mass, I am very sure you all are aware of it. It's the amount of matter contained in a body. Mass is the amount of matter contained in a body. It determines the inertness of a body basically. So it is the amount of matter contained in the body. Charge, as I've told you, just now we have discussed, it is a fundamental property possessed by few elementary particles like electrons, protons, not neutrons, by virtue of which they tend to exert upon each other an electric force of attraction or repulsion. depending upon the nature of the charges, right? So it's a fundamental property. So that's the first basic difference. Second, mass of a body can't be zero. Every material body is made up of atoms and molecules. Every atom is made up of protons, neutrons, electrons, isn't it? Further, protons, neutrons, they are made up of quarks, up quark, down quark. Anyway, that is beyond the scope of your syllabus. You will learn about it in higher classes. But what I mean to say is that every body possesses some sort of mass. It can't be zero, it can't be negative. So mass of a body is a positive quantity. So mass of a body is always greater than zero. While on the other hand, we have discussed charge. A body may be neutral. So the net charge on that particular body is zero. So charge can be zero. We'll represent charge by a small letter q, right? Then if a body loses electrons, then it will acquire a net positive charge. If a body gains electrons, then the body will acquire a net negative charge. So charge can be zero, net charge on a body can be positive, net charge on a body can be negative, right? Third, mass is not conserved. I repeat, mass is not conserved. It can be converted into energy. Again, we have discussed it. We'll discuss it in +2 in nuclear physics as well. We are aware of this particular formula. Einstein's energy mass equivalence relationship equals to mc square. So mass can get converted into energy and vice versa. So mass is not conserved. It is convertible into energy. The mass is not conserved. While charge is conserved. It is again a very, very basic difference between mass and charge. Right? Then, charge is quantized. We have discussed charge is quantized. That is, the net charge on a body is given by some integral multiple of smallest unit of charge. While on the other hand, the quantitation of mass has not yet been established. Smallest unit of mass, we are unsure about it. So the quantitation of mass has not yet been established. Another point. Mass of a body is dependent upon its motion, while the charge, net charge on a body is independent of the motion of the body. So that is known as invariance of charge. So these are some basic differences between mass and charge, isn't it? So I hope, these topics which we have discussed right now, it's very simple. We have started with fundamentals, very basic concepts, and later on we can subsequently raise the level, isn't it? So in the next lecture, we'll discuss Coulomb's law, and then Coulomb's law in vector form, its utility, its importance, concepts, numericals based on Coulomb's law and all that. So what we have studied in this lecture is electrostatics, right? Branch of physics that deals with the study of electric charges at rest. Throughout the unit, we'll be dealing with point and static charges only. We have discussed about charge, the actual definition of charge. We'll discuss some other definitions of charge as well, but the actual definition of charge. Then various methods of charging a body, charging by friction, charging by conduction, charging by induction, along with examples, right? Then we have discussed some properties associated with charge, conservation of charge, quantitation of charge, additive nature of charge, invariance of charge, and so on. And lastly, we have discussed basic difference between mass and charge. I hope you will recapitulate this topic and go through this video thoroughly and clear your concepts, basic concepts. So we'll discuss the next topic, Coulomb's law.